Okay, now we're going to start assignment 11. I know it's kind of tricky finding the data because all kinds of other layers start showing up. I don't know why it's not more specific. I guess if we had said something about author, maybe it would have brought you directly to just the one that I had. But, looking up and down, you were able to find them. And so we had to get the watershed layer, the soil taxonomy layer, which has like mapping units and taxonomic names. And then we had to get the vegetation layer, which has things like chestnut, oak, and alpine forest and things like that. So that's what the first step was all about, was just getting all those layers into, which is just three, just the watersheds, the vegetation, and the soil. So now you can see all three of them are in there. Now I'm going to end up putting the watersheds on top, and I'm going to symbolize it by a hollow fill and a 2-point blue outline, just so I can always see the watersheds on top of my analysis. So I'm doing that by going to symbology, changing the fill to no color, and changing the outline to a 2-point blue line. And then I'm going to move that layer up to the top so that we'll always be able to see the analyses underneath, outlined by the watersheds that are selected at the time. And as you can see now, you can see the watershed outlines on top of the vegetation layer. So next we're going to find that Abrams watershed. So it's in the name, and it's unique, and it's the Upper Abrams. So you kind of have to search through a little bit. Now don't do the apply, filter, and zoom, because then you'll start chopping off your analysis. So you should just apply the filter. So even though you can't see all the watersheds, you should still be at least zoomed out to the whole area of the park. And so we want to extract the soils layer, and not as the display. We want to do the watersheds, and the one that we have selected is the one, the filtered one. You can do different ones, but we're just going to do a shapefile. It's a pretty one, easy one to extract and to re-upload to your map. So we'll call it Abrams Creek, and run the analysis. And it will go ahead and start kind of just pulling out those pixels in that layer. I shouldn't say pixels, it should be the features, polygons in that layer that are just in that Upper Abrams watershed. And then you go over to your content. I actually brought mine up in a separate tab so I didn't have to leave my map. And I searched for the layer in the file, and it was in my downloads, which is where it usually defaults to. You can see Abrams Creek soil zip is there. And I say import layer. I'm going to generalize the features. It just makes the number of features smaller, so it should come in a little faster. That's fine to do. And I'm just going to symbolize it by its mapping unit name. So that's all you had to do for that first step of doing a clip. And as I said, it's a little bit more complicated than it should be. Hopefully they'll make it a little bit easier down the road. So now we're going to get all the watersheds back again. And now we're going to search for watersheds that are bigger than 30,000 30,000 acres. And once again, don't zoom. You want to make sure that you have all the watersheds in your zoom so that you're not chopping off your analysis. And, you should be able to kind of see what the analysis should look like. It should have all of the areas outlined in blue, but none of the areas that are not outlined in blue, because we're going to erase them. So we're going to go to the overlay method called erase, and make sure you go back to your original data. We're going to erase the soils data by just those watersheds that are selected using erase. So we're going to erase the large watersheds and run our analysis. And then when our analysis is done, you can see that those watersheds that were selected are now removed. So then the final thing we're going to do is we're going to find in that vegetation layer the eco groups that are chestnut oak. And once again, apply filter, don't zoom to because you don't want to chop off your analysis. And you can see it's just certain polygons that get up, so that's just the perimeter of the park where the chestnut oak is a little bit more predominant vegetation type. We look at its table, we see it actually does not have any soils data in it at all. It has just the vegetation data, at just those attributes in its table. So we're going to do an intersect so we can pull in from the soils layer all the soils information for those same polygons that have the chestnut oak. So we're going to go, and you have to make sure you override these. We're taking the input layer, the vegetation, the overlay layer is the soils, and we're going to intersect these two so that we end up with a combination of both the chestnut oak polygons and then the soils information for those polygons. We actually could have done this at the end. We could have just done the whole analysis first with everything selected and not just the chestnut oak, but it would have taken up a little bit more credits and time. So that's why I did the filter first. So now when we look at the new table, you should have 16951 features. Now you can see it has soils data in it. And that's because we combined it using that intersect. So now I'm going to go ahead and symbolize it by that taxonomic name, which I couldn't have done if I hadn't done the intersect. So that's how you're able to pull in that additional data into this original layer of the chestnut oak. And that is it.